doing today, Angela?
I'm fantastic.
Excellent. You're looking great. I'm digging that Phillies brim.
Thank you. Thank you. You're
Yeah,
looking
because
very dapper yourself.
thank you. I try.
Gl-
I try. It's
Glad to be
spring has
back with
sprung.
you.
Yes. I had to push last week, but here we are today. I'm feeling 100. Well, 99.9% better. So apologies, folks, if I sniffle or sneeze or hear me a little bit raspy in this discussion. I'm getting over a cold, but I am here today and I'm ready to chop up this topic.
I love it. Well, again, glad to have you back.
Yeah, yeah,
And
no
we are
doubt.
doing what? What are we talking about? Lambda.
Lambda, the book that we are discussing in this particular season is Programming AWS Lambda, and we're getting into it.
Whew.
We are definitely learning some lessons, some new stuff. Java is the code of choice for these particular authors. It's been giving us some,
Fits?
uh, yeah. I was trying to think of a gentle word.
No, no, we won't. We're going to do it. We're going to be real honest about this. Neither one of us are Java developers.
We are
So,
not.
uh, yeah, this is going to be what you get.
Yeah. Well, and I am a Lambda user, so I appreciate their take on the features and functions of
Yes.
Lambda, and we'll get into all of that in this particular discussion. But some of the Java back and forth, it is what it is. And God bless you, Java developers, if you're listening or watching. We appreciate you and all of the enterprise development that you do. It's wonderful. I love it. It's great. But I'm just saying, Python for me. So that's all I'm gonna say.
There you go. One word.
Yeah,
Python.
give me
And
give me the snake.
so a caveat. If you are going to dive into this book, you should have a Java background.
Yeah,
This is not 1, 2, 3, learn Java. No, it's coming into it with an understanding. And also, this book was written a couple of years ago,
yeah,
so the example code and everything in there. There's versioning issues with the version of Java. There's issues with the versions of the tools that you're using and whatever. So just so you know, if you do get into this book, just be wary of those two little caveats, because they will cause you a little bit of consternation, even if you're just like following instructions and it's like, but it should work, and it's like,
right.
well, no, it's not. It's not going to work.
Yeah,
But we're learning the features and functionality of Lambda, and Java is just the mechanism. So if you take all of that aside, this is you're learning programming in Lambda, in AWS Lambda. So uh, all is not lost.
yeah, yeah. The topics, the content, I'm really enjoying that, and it's applicable to any of the languages that the Lambda runtime supports. And we even talk about the execution environment here in just a little bit. But if you're a Golang developer, JavaScript, Ruby, Python, shout out to the Snake Gang. You could still benefit from Lambda and the features and functions that it has. You just have to apply them to your code and not necessarily to the Lambda code. So, or
Yeah.
rather, not to the Java code is what I meant to say. Yeah.
All right. So where do we want to dig in?
Well, I think we can dig in or jump in at the beginning of
Okay.
the chapter. They really jumped right into the runtime, the Lambda execution environment, and kind of how it all fits together. I know we talked in our last discussion about how Lambda is serverless. There's no servers that we have to worry about, but there's a
Mhm.
computer somewhere running our code. And they, in the beginning of this chapter, kind of give a description of how all that fits together.
Yes. So we should probably start at the second page in the chapter, which
Yeah,
has
yeah,
this
no
really
doubt.
cool graphic.
You want me to bring that to
That
the stage here?
Yeah, bring it to the stage.
All righty.
We'll talk a little bit about the Lambda execution environment. So there's of course multiple ways to do a lot of things in technology, and this is no exception. So you can run it from the management console, or use the invoke from the CLI, and the same thing kind of happens. It's going to do a number of things in a very particular order. So both make use of APIs. AWS is an API first cloud company. Everything can work from an API,
Mhm.
and the so this image is important. So the API really kicks off whatever you're doing. So we'll start with invoke, because I think it talks about that quite a bit. And this is when it invokes the function, and when it does it, the Lambda service creates this host environment, right? And this is what Michael just said. There is a server involved, and it's like this micro VM or whatever you want to call it. And once that host environment is created, if you're not running Java, but whatever your runtime is, the example code is missing like the main method, but it's inside of the Lambda runtime. So it's there. That's the next thing to be started. And then you see the Lambda runtime. And then the final step in this chain is load your class and then call the handler method, right? So that is it. This is, if it's not JVM, it's some other runtime, but all the other machinations are pretty much the same. And there's a, yeah, that's. I wanted to make sure that we showed this. This is an image from the book on page 42, and it kind of goes through the chain of activities once you
Yep.
invoke a function in Lambda. So, any thoughts?
Yeah, one of the things that, and I'm not sure if they really went into, maybe in the previous example we talked about it and they went into it a bit. Just thinking about how all these things come together, but they come together so quickly. So
Seamlessly.
it's like, yeah, the Lambda service is there, it's running, that's AWS doing their thing. You invoke your function and they start the host environment, they start the JVM, they spin up the Java runtime for Lambda, and then they run your code, and then they give you the response. And we're talking like less than a second. All of this stuff just kind of happens, and I'm like, wow, that's mind blowing, right? I mean, it's probably the same as if you were run it on your local system. It'd be pretty quick, but if you think about all of the different things that have to come together on their side to run your
Mhm.
code, it's like, wow, they're doing this at scale, and it's happening very, very quickly. So kudos to AWS and all the other serverless function folks out there that are killing the game with this particular compute execution model.
All right. So
Yeah.
I use the word invoke, and you see it there on the image. And there's for Lambda, there are two invocation types, and there's the synchronous. And if you saw in the example, there is an invocation type request response, and that's when you wait for the function to execute, and you receive your response. And it's used, when you're running the CLI or you need a result from something. But most Lambda runs asynchronously, and that's when you're using the invocation type event. It doesn't have to wait for you. It queues the request and it processes it in the background. There's no waiting. Most, like it says, most classes kind of work with this. Any kind of event driven applications,
Mm-hmm.
if you're using SNS or anything like that. Like there was an example in the previous chapters where they were talking about this photo processing example where
Mm-hmm.
you upload a photo and it kicks off this Lambda function, and it resizes the photo and yada yada yada. We've seen that example a few times, but those are the more common types of invocations that you're going to see in Lambda, and this book just differentiates against the two.
Yeah. I will say I'm a big fan of the request response invocation type, mainly because I use Lambdas like mini web servers, if you will.
Okay.
I'll have a Python function that basically returns HTML. So it acts a lot like a web server, and you want to get that response from the web server.
Yeah.
So you got to sit there and wait for it. It's super fast, though. Again, less than a second, millisecond response time. But you don't have this whole server to manage, and also you have the benefit of it has connections to the other AWS services. So you can have a web service type thing that connects to a database, that connects to a SQS queue or messaging system or whatever. And it all just happens. The Lambda is kind of like the orchestrator, but it's acting like this little web server that just, spins up, does its thing, spins down. And if you're using Lambda URLs, again, I'm a big fan of Lambda URLs, so I'll keep harping about those things. Then, you have easy access to your function and all that it can do. With the event method, I like those too. I just don't use them as often, but typically if it's just a like a batch process, like this is a function, it's going to do some stuff. I don't want to sit around and wait for it to respond. Maybe it takes, more than 2 or 3 seconds to run. So I'm not going to sit there and wait. I'm just say, hey, function, do your thing. And then I'll pick up the file or, look at the logs or whatever the case is when the execution completes.
All right. So, and if you're working, if you're keeping up with us or you're watching this somewhere later, be sure that if you're editing the, I think it's the template file, make sure you change the version of Java so it runs. So anything over 11 will run. And before you do the SAM deploy, make sure you review the Lambda console, and you might have to clean up some initial runnings in there. But other than that, that's all I want to say about that. What else?
Yeah. Hello World was pretty easy to get through. We talked about the sync and async. They went into the input and output with the handler, and me being the Python guy that I am, I typically use JSON objects, but they went into great detail to describe the inputs that Java can accept, and I mean other runtimes as well, but strings, booleans.
Yes.
They even went into a POJO. I had never heard of a POJO before.
Nope.
A plain old Java object. I mean, okay, you learn something new every day, right? So I'm going to have to read up some more about POJOs. But when it comes to inputs for me, I'm straight JSON. Give me the JSON in and out, and I'll be happy with it.
So you're the input output section, and yes, let me make sure I'm on the right page.
If I scroll to it, it's page 47 is where they start talking about input and output.
So this was interesting because in real use cases, the JSON object usually is an event coming from somewhere else.
Yes.
Not the way you're using it again, but another source. And what happens is the runtime will deserialize or serialize if it's just like if it's a JSON payload. And I was like, what? I kind of knew what it meant, but I wasn't sure. So I had to look it up because it's doing something very specific depending on what's being passed into the function. And when an application receives a JSON payload, of course, it takes other things, formats. It needs to convert it into a Java object so that it can be processed and used in the application. So this conversion is called, we're deserializing it. So it comes in, it receives the JSON payload, and then it winds up being a Java object. And then the inverse is when the serialized part, where it involves converting objects into JSON. So I think in the output file.txt, the payload was just the string, so it had taken the object and serialized it. So putting it in layman's terms, basically, that was what was happening when you ran that code.
The one thing that I struggled with the Java inputs and outputs are, I guess it was the specificity of the function and what it returned, because I'm used to Python. It's like, hey, I'm returning what I'm returning. You could take it or you could leave it, right? And with my lambdas, my Python lambdas, I almost always just look at the event and the context object. And they also talked about those as well. But that's where like my functions get a lot of their information from. It's either the context, the event, or the environment, which we'll talk about here in a little bit. And I don't have to do anything specific to the function that in terms of what I'm accepting or returning. But Java is very specific about the type of function, the inputs that it receives, and the values that it returns as output. So that was new to me as well, or just a no, I mean a reminder, I guess, to say, hey, this is a very what they call it, like a strongly typed
Very
language
much
here,
so.
where
It's
yeah, you have to be very strong with the or very specific about what you're passing in and out.
right, and they're called primitives, if I'm not mistaken,
Hmm.
where it's a specific data type that's used, and it can be like a byte, a short, an int, a char, a boolean, a double, and
Yeah,
again very specific. Python be like, give me what you got.
I know, right?
It's not it's not gonna, him and haw. Anyway,
No worries.
yes. So Java is very specific, and that's why, in my opinion, because I've learned them both in the past, and I thought Python was much easier than Java.
Hmm.
That was just my personal opinion. I struggled
Mm.
doing Java. I remember my tutor was like, we'll just have to keep at it. Shout out to LeBron. He's on LinkedIn.
Okay.
And I know he remembers. I was just like, okay, this is hard. This is way harder than it should be. And then Python came along. I was like, this is
Yeah. You mean I could print something with just one line?
what? Yeah. So back in the day, but yeah, very strongly typed versus loosely typed.
Yep, indeed.
All
I'm just scrolling.
right.
We lists and maps and arrays and all that good stuff. Of
Yes.
course, you have to change your function to accept and return those types.
Yes.
We talked about POJOs and how that was a different sort of serialization and deserialization approach. Um, I didn't do the streaming example or the streams. I wanted to get to that one. I read through that one, and I was like, okay, this is pretty cool. I see what they're doing here. I've never used a streaming input or output with Python functions, so I
Mm-hmm.
think I am going to go back and just kind of mess around with that one to get a feel for
Okay.
how they work
Using a
with streams, yeah, for input and output.
okay. Yeah, I did read up on that as well. I'm trying to see if I have some notes about it. Because I'm still looking. Maybe not. I thought I had some notes about streams somewhere. But anyway, oh, I do. Here we go. Um, input in Java, in the Java IO package, right? You
Hmm.
see that when you're importing it in the beginning of your function. Um, Input and output stream, they're abstract classes that serve as a foundation for handling byte-based input and output. Now,
Hmm.
again, we're talking primitive. Byte, I'm sure, is one of the Java primitives, and it's for reading data and writing data. So you think about when I hear that, I think kinesis.
Yeah,
But
kinesis streams. Yeah.
yeah, that's what I think when I hear it. But it's interesting that there's input output streams. I wish I wish I would have gotten this far and did the example as well. Maybe I'll dig back into it to see what it's like. But um, yeah, you didn't get a chance to take a look at it either, right?
No, I didn't. I read through it. With the difficulty that I was having as a very, very novice Java programmer was bringing this new code into my environment.
Yeah.
So the authors, they give you, all these different examples, and you're basically using the same class
Yes.
and the rather the same package, but the classes within the package, they need their own separate files, and then you have to go back, you have to update the template, the SAM template,
Always.
with the handler that you want to use for your next invocation. And I just kind of got tired of going back and forth, to be honest. So I was like, I want to do a separate basically a separate instance for each one of these examples, so I could
Mm,
have a standalone place to look at, okay, this is what a Boolean input looks like, this
right.
is what a streaming
That's
input looks like.
interesting.
Yeah,
So,
I didn't want to like lose the example that I just created to get to the new example.
and you're doing that because they're like, go back to this file and edit it. Go back to
Yes.
this file and edit it. And go and you're with so in a lot of learning platforms, learning uh, books or whatever, they usually keep each example separate. So you
Yeah.
can kind of go back and learn. I know LinkedIn is famous for that, where
Mhm.
each chapter it iterates, and if you don't pick up here, you can kind of pick up it. If you didn't get
Yep.
everything right, there's a solution. It shows you, and I don't recall that being the case. If I am, correct me if I'm wrong.
No, no, I don't think so. And just
Okay.
like sidebar reflection, I do for the benefit of if you're listening or watching, I do produce content for LinkedIn Learning. And for my exercises, I'll create a new repo for everything. Like it's within a chapter, but there's folders within the chapter, each exercise. And I once had a student comment, is like, you mean we have to create a new repo for everything that we do? And I'm like, my response to them in the Q&A, I was like, yeah, because I want you starting from a clean slate every time. Because if you have some code that's lingering around from the first example or the last example, it might break what you're doing
You
now.
don't want
So yeah, hey, let's start from a clean slate. If we're doing a course on GitHub Actions, yeah, you're going to be creating dozens of GitHub repos. Hop on board and
it's
let's
for
learn
your
this
own
code,
good.
right? So anyway, that's a sidebar. You get me on a tangent now.
I'm so sorry to do that.
No, it's all
What
good.
else we got? What else we got here?
I had a couple more things as far
Please.
as the configuration. Well, we talked about the context object, and again, like it is giving you metadata about the execution environment and the way that the function was called. So you can use that information in your function to know like how much memory you're running with. Yeah, if you need reference to the function name, function version, request ID, where the logs are. There's all this information that the function can use if you want to tap into that. The event also has information about the way that the function was called, is like in particular, the methods. I don't think they really went into detail in this, but that's where you'll learn if it's a put or a post or a get or a delete or whatever, if you're
Mm-hmm.
using these HTTP methods to invoke your function. They also talked about timeouts for
Mm-hmm.
long running functions. The global limit or the default limit is 15 minutes.
Right.
And you definitely don't want your function running that long if you don't have to. So you can put limits in like directly in your Lambda configuration to say, hey, this function shouldn't run any longer than 2 minutes or 3 minutes or whatever the case is. And if it does run past your configuration, then the Lambda system itself will stop your
We'll
function
stop
to
it.
say,
Yes.
yeah, hey, your function is running longer than what you told us to let it run for, so we're just going to stop it for you
Yeah.
automatically. So that's
The the example in the book defaults to 3 seconds.
okay. Okay, cool.
So it won't hang out. And like you said, if it's running for 15 minutes, which is the maximum, you might need to rethink your architecture.
Yeah, no, you might just want that server, yo.
Yeah, I think so.
Yeah.
What else you got there?
A couple more things. Memory and CPU, and I'm
Hmm.
glad that they followed this with a brief discussion on cost. Mainly because you don't pick a server size when you run when you configure your function, but you can tell it how much memory it has available to use, how much CPU it can use. But that comes with a cost, because the more memory and CPU you say this function can use, the more AWS is going to charge you.
Right.
But you have to kind of leverage that with how long you want your function to run. And I thought the example that they gave was a very, very good one, because they said, with this function that's using 1.5 gigs of RAM and has to do this many operations, is going to cost $75 a month, which is, it's kind of pricey. You might want to consider a server. But then they reconfigured it with 512 megs of RAM. Let's see, make sure I'm saying this right. I said gig before. Um, and then they did something else. What did they do differently? I'm skimming through the document here.
Hmm.
Whatever they did differently, they got the cost down to $21 a month. So I believe they either increased the RAM or increased the CPU to give it
Right.
more room to run faster. So the function was actually executing faster, which means it was able to process more in a shorter period of time, which actually saved cost. So I'll go back through and make sure I got my numbers right. But
Yeah.
I appreciated that they said, hey, you do have to consider cost along with the memory and CPU that you use to configure your function.
And it in the section where we're talking about memory and CPU, and
Yep.
and they're talking about how expensive Lambda is, it used the photo resizer example again, which it'll come out throughout the book, and talking about if you're setting it for one set of RAM and it takes an average of 10 seconds and you're processing 10,000. So it gives you this math equation that
Mhm.
shows you this is how much you're going to be charged. Like he said, $75 a month. But when you make small changes, and $75 a month is about the same cost as an M5
As a
large.
server. Yeah.
So that's a lot of money.
Yeah.
But when you reconfigure and change some of the, maybe the memory, the CPU, or shortening the runtime or whatever, that's where the savings come in. And he mentioned that one at the bottom. I think it was it more RAM?
Yeah, well, the first one was 1.5 gigs with an
It was
average of
less
10
RAM for the
seconds to
second.
run. The
Okay.
second one was less RAM and a shorter runtime.
Yes.
So because they weren't using as much RAM as the previous example, they were shortening the runtime, then they were able to get about the same amount of execution for less money. Um, so yeah, that was, I thought that was a pretty good analysis there. I really did appreciate that.
Definitely. All
Yeah.
right, on to environment variables.
Then they got into environment variables, which
This
kind
the
of
juicy
touched,
part.
yeah, this touched my heart because I like using environment variables in my Python code. And I
Show me
even
your
have an
example.
example to share with you all today. If I can get my screen set up here for the folks that are watching us in video. Um, and if you're listening in, what I'm showing right now on the screen is a CloudFormation template that I use to deploy two Lambda functions, one for a staging environment and one for a production environment. And now some people will say, why are you deploying two functions? You can use function aliases on the same function, and you can make changes that way. I prefer to deploy things separately. So if I break something while I'm testing out a function, or I want to do something crazy, then it doesn't break the whole thing. I've only broken the one environment that I'm working on, and maybe I have the other environment to fall back on. But what I've done for each of these functions is I'm passing in environment variables to the Lambda properties, and I'm highlighting them here on the screen. I've got an environment variable literally named environment, and another one named version, another one named platform, and another one named build number. And so these will be added to the execution environment for each of these Lambda functions. And so I run this template, and I'll share it in the repo for the course. And I get to Lambda functions. And as I'm showing my screen here, you can even see this is my hello world Lambda function where I was messing around with the author's code. And these are my two functions here, the production environment for the sample application and the staging environment. So the way that these environments are surfaced in the function is there is a configuration page. So now I'm looking at the Lambda page for the staging function. And on the configuration tab, there is a sidebar, and on the sidebar, there's environment variables. And each of those variables that I configured in the CloudFormation template are presented here with the default value that I had in the template. So I've got the build number, it's 0, the environment, the platform, and the version. The key demonstration, or the key feature for this particular demonstration, is the environment name, where I'm naming it staging for the staging environment and production for the production environment. And the way that I surface that, or the way that you can see that in the code, is when you access the function using a Lambda URL, which I'm just kind of crazy about because I love it as an easy way to get access to functions that return HTML, is the Python code is basically reading the environment variable. And actually, let me show that really quick too, because it is in the Lambda function. So here's the handler where it gets the event, it gets the context, and it reads this variable called environment, and it assigns it to a variable called environment. And so I'm using that as the title for the page. I'm saying, welcome to this environment. And then later on, within the actual body of the HTML, I say, this is the whatever the environment is environment. So the way that surfaces when I execute or access the URL for the staging environment, I see, hey, this is the staging environment. And even in the tab up here, it says, welcome to staging. And then the same thing for the production environment. This is the production environment, and then welcome to production. So I just find that it's really useful to, number one, deploy two separate functions, so I can, sort of practice on the staging environment. And then once I have whatever I'm trying to do down, then I can deploy it to the production environment. And also when I'm trying to explain different things to different people, they can sort of see how these environments are separate and applied. The and I mean, this is just kind of a contrived demonstration here, but the way that this is useful is if you have other resources that you're attaching to, like databases or queues or S3 buckets, and you have these resources configured for different environments, then you can update your function environment to deploy or to connect to rather the correct database, the correct S3 bucket, the correct SQSQ, and so on and so forth. So I really like environment variables. I could probably go on and on, but I'm going to remove that from the stage so we can land this plane and not have me go on and on about environments and how they're used in Lambda.
Fantastic. And a great example in Python instead of Java.
Yeah, Python.
So
and I had to set my title today for Team Python. So that's me. Yeah,
I love it. I love it. It was a great example. Yeah, so that was chapter 3. Neat in a little bow. There's a lot to go through in this chapter. What it means to program in Lambda Lambda functions, how the runtime environment comes about, how functions are invoked, the aspect of the configuration of Lambda functions, timeout, memory, all those settings, and how to apply your own application configuration through environment variables.
Yep, got to use them.
So, we're going to be back here next week? Chapter 4. Wait, let's see.
Yeah. Well, I've got a banner for it. Next
chapter
up is
4.
Operating AWS Lambda Functions. And this goes into more like, what it takes to build and run your function.
Okay.
Getting actually onto the platform and making sure your function is ready to go. So I'm curious and interested to see what they discuss in this particular chapter. Again, because I know they're going to be coming from the Java perspective, and I'm coming from the Python perspective. And I mean, I don't want to get ahead of myself, but you're basically bundling your code up. You're uploading it to S3. You're uploading it to Lambda, and you're saying, "Hey, this is my code. Let's talk about it. Let's run it." So I'm curious to see what that looks like for Java functions.
Awesome sauce. All right. Well, I'm looking forward to chapter 4. Again, I am not a Java person, so this exercise for me is totally academic. I love the fact that it's academic. Yeah, I like I said, I tried my attempts in chapter 1, 2, and 3, and I was like, nope, I'm wasting way too much time. I'd rather understand the meaning. I'd rather understand this in a very academic way, because I think at some point you and I are going to have a book maybe about Python or something, and it's going to come back around.
I can't wait.
All of this crap that I've learned, I might be able to apply it at some point, and that would be
no
pretty cool.
doubt.
So I'm very excited for chapter 4.
Cool. Before we bounce, I just want to give a shout out to Mark Twain, who's joining us from YouTube.
Hey.
He says this is a fantastic topic. Excited to learn from you. If you're watching this at a later time, if you're not joining us live, we do record this live for this particular reason, so that people can join in to the conversation. So watch out for the announcement on YouTube, on X, on LinkedIn, and then join us for the live stream. Mark Twain did have one question that I wanted to answer really quickly before we bounce. He asked, how do you handle secrets? And again, I'm going to try to be brief, because again, I love Python. I like Lambda, and I like the way that it integrates with other AWS services. And so basically what you do is there's a role that is associated with your Lambda function. And it's just like any other entity in AWS. You have permissions to do whatever you want to do. It's designed or assigned by IAM, roles, policies, groups, and so on. So basically what I do is I assign a role to my Lambda function, and that role has a permission policy attached to it that gives it permission to read whatever secrets I want to give it access to. I like parameter store because it's free. AWS Secrets Manager. I think they charge you $1 per secret or something like that, but
Mm.
Parameter Store is free. And basically, again, using the example of environment variables, what you can do is you can write secrets that are specific to an environment and then limit the permissions so that the function can only read that environment. So if something escapes, permissions or whatever from that function, and somebody tries to read production environments, production secrets from the staging function, you don't have permission to do that. So that's just one of the ways that I handle secrets and other parameters in Lambda functions that I don't write as environment variables. I just put them in parameter store and then give the Lambda function permission to read from parameter store so it can access it there.
Awesome sauce. All right. Well, again, thanks for listening. This is From Cover to Code. Make sure you check out our replays. Our last season, we did a DevOps book. This season, we're digging into programming AWS Lambda. Who knows what we're going to do next season? But right now, we are in it. We are in it thick with AWS.
We are in it. We are up to our Adam's apples in Java. Okay. Yeah, we are taking it all
begrudgingly, like, because I don't know Java, but I am learning as we go, and I guess that's the whole point about why we do this, because there's a teachable moment in everything.
There is.
Who knows? I might have a project come up. Angela, I need you to create these Lambda.
Yeah, right. and then watch. They're going to say, and we're going to be doing it in Java version 21.
And that, you know what? Bring it on.
Right. You'll be ready.
Awesome. I'll see you guys next time. Nice seeing you.
Good to see you as well, Angela. Always love the discussion. Thank you all for joining us live. Thank you for watching the replay. And we will see you next time right here on From Cover to Code. Bye.
Bye.